In the decades following the Second World War, the United States confronted a strategic reality that defined much of its Cold War military planning. The majority of its heavy combat power, industrial base, and manpower reserves were located across the Atlantic and Pacific from the primary theaters in which it expected to fight, particularly Europe and Northeast Asia. And this geographic separation meant that any sustained conflict would depend not only on airlift and forward-stationed forces, but on the reliable movement of massive quantities of equipment, fuel, ammunition, and supplies by sea. Within this framework, the military Sealift Command, formally established in 1949 as the Military Sea Transportation Service and later renamed, evolved into a central pillar of U.S. war planning. Providing the maritime transport capacity necessary to convert continental strength into forward-deployed combat power. The core strategic problem was one of tonnage and endurance, because while aircraft could move personnel rapidly, only ships could carry the heavy armored vehicles, artillery systems, aviation fuel, munition stockpiles, and sustainment supplies required to support prolonged high-intensity operations. Early Cold War mobilization models revealed that without guaranteed sealift capacity, reinforcement timelines would stretch beyond acceptable limits, undermining deterrence credibility. Consequently, the United States invested in a hybrid maritime logistics structure, combining government-owned vessels, chartered commercial ships, and a reserve fleet maintained in various states of readiness. This structure allowed Military Sealift Command to scale capacity during crisis, drawing upon pre-designated vessels enrolled in support programs and integrating them into mobilization schedules. Sealift planning was embedded into NATO war plans, with detailed calculations specifying how many roll-on roll-off vessels, container ships, and tanker transports would be required to move divisional equipment sets and sustain them during the opening phases of conflict. Ports such as Bremerhaven in West Germany and other key Atlantic entry points were identified as primary reception hubs, and infrastructure upgrades were coordinated with host nation authorities to ensure rapid offloading and onward rail movement. Military Sealift Command also managed afloat pre-positioning concepts in later decades, recognizing that storing equipment at sea near potential theaters could further compress response time. The strategic logic remained consistent throughout the Cold War. Maritime transport provided the bulk lift capacity necessary to project power across oceans and sustain it once deployed. Exercises and mobilization drills repeatedly tested port clearance rates, cargo handling procedures, and coordination between sealift assets and rail authorities, generating documented performance data that informed planning assumptions. Intelligence assessments during the 1970s and 1980s indicated that adversaries closely monitored U.S. sealift readiness, understanding that disruption of maritime transport could significantly degrade reinforcement capability. The evolution of Military Sealift Command reflected recognition that sustained combat in Europe or other theaters would depend on continuous maritime resupply, not merely initial deployment. Fuel tankers were essential for delivering aviation fuel and naval bunker supplies, while ammunition carriers and equipment ships transported the heavy material foundation of land operations. As U.S. force structure fluctuated and forward-station troop levels shifted in response to political and fiscal pressures, sealift capacity provided strategic flexibility, allowing planners to maintain a credible reinforcement model without permanently expanding overseas garrisons. By integrating government-owned ships, commercial charters, and reserve vessels into a unified command structure, Military Sealift Command institutionalized maritime logistics as a core element of Cold War war plans. Its role extended beyond simple transport, encompassing scheduling, cargo prioritization, port coordination, and sustainment forecasting, ensuring that transoceanic movement aligned with operational timelines. Throughout the Cold War, the measurable throughput of ships, the availability of tankers, and the readiness of reserve fleets became indicators of strategic credibility, illustrating that maritime logistics underpinned the feasibility of U.S. global defense commitments. In this way, military Sealift Command became essential to Cold War war plans by transforming geographic distance from a structural vulnerability into a manageable logistical challenge supported by organized, rehearsed, and scalable maritime transport capacity. As Cold War strategy matured during the 1950s and 1960s, the operational importance of military Sealift Command became more precisely defined within formal mobilization planning, particularly in relation to NATO reinforcement timelines and global contingency operations. U.S. planners recognized that while strategic airlift could move personnel within days, the heavy equipment of armored and mechanized divisions, including tanks, self-propelled artillery, engineer assets, and large ammunition stocks, could only be transported economically and in sufficient quantity by sea. War planning documents therefore calculated deployment schedules in phases, with initial personnel arrivals often preceding the bulk shipment of equipment and sustainment cargo aboard Sealift vessels. This sequencing required close coordination between port authorities, rail networks, and forward depots, ensuring that arriving ships could be offloaded rapidly and that cargo could move inland without congestion. Military Sealift Command maintained detailed readiness rosters for its government-owned vessels and for commercial ships enrolled in support programs, allowing planners to estimate how quickly additional tonnage could be activated during crisis. The Ready Reserve Force concept evolved to maintain selected ships in reduced operating status, crewed by skeleton personnel but capable of activation within specified timeframes, thereby bridging the gap between peacetime commercial shipping and wartime demand. Port infrastructure became a critical variable as major embarkation hubs in the United States required sufficient loading cranes, storage yards, and rail connections to handle surge operations. Similarly, European reception ports such as Bremerhaven were upgraded and exercised to ensure rapid discharge and onward movement of cargo. Exercises linked to NATO reinforcement scenarios frequently incorporated Sealift components, measuring turnaround times, pier clearance rates, and the synchronization between arriving ships and rail transport to forward assembly areas. Fuel logistics received particular attention, with military Sealift Command tanker capacity integrated into planning models for sustained air and ground operations, recognizing that aviation fuel demand in wartime would far exceed peacetime consumption. The command's fleet included specialized vessels designed to carry ammunition and hazardous materials safely, ensuring that high-value cargo could be delivered without excessive risk during transit. Intelligence assessments indicated that adversaries monitored U.S. Sealift activity, treating mobilization of reserve ships as an early indicator of potential crisis escalation. This awareness influenced operational security measures, as planners sought to balance readiness, transparency with strategic ambiguity. The growth of containerization in commercial shipping during the 1970s also influenced Sealift planning, as standardized containers improved loading efficiency and cargo tracking, reducing time spent in port and enhancing throughput predictability. Military Sealift Command integrated these technological and commercial developments into its operational model, ensuring compatibility between civilian maritime innovation and military logistics requirements. Throughout this period, the command functioned as a connective tissue between the U.S. industrial base and forward theaters, translating domestic production and equipment stockpiles into deployable assets across oceanic distances. By institutionalizing reserve fleet activation procedures, port coordination protocols, and cargo prioritization systems, Military Sealift Command ensured that maritime transport was not improvised during crisis, but embedded within rehearsed and measurable war planning frameworks. This integration of sealift capacity into NATO and global contingency models underscored that sustained Cold War military operations depended fundamentally on maritime throughput, making Military Sealift Command an indispensable component of the United States' ability to project and sustain power abroad. By the 1970s, Military Sealift Command had become structurally embedded within NATO's reinforcement architecture, particularly as U.S. force posture shifted toward a model that relied increasingly on continental-based units supported by rapid deployment rather than permanently expanded forward garrisons. This shift heightened the importance of predictable maritime throughput, since large volumes of heavy equipment and sustainment supplies would need to cross the Atlantic under compressed timelines. Sealift planning was integrated directly into NATO operational documents, with specified shipping lanes, port reception points, and discharge priorities aligned with anticipated deployment sequences. Ships were assigned pre-planned cargo loads based on unit type, ensuring that armored brigades, artillery formations, and support elements received their equipment in coordinated waves rather than fragmented shipments. Roll-on, roll-off vessels gained increasing prominence because they allowed wheeled and tracked vehicles to be driven directly onto and off ships, reducing port handling time and minimizing crane dependence. Container ships were adapted to carry ammunition, spare parts, and packaged sustainment goods, benefiting from the efficiency of standardized cargo handling systems. Military Sealift Command maintained detailed coordination with U.S. Transportation Command elements, aligning sea transport schedules with airlift personnel movements so that arriving troops could be paired with equipment and supplies without prolonged delay. Port exercises conducted in both the United States and Europe measured clearance rates, labor coordination, and rail interface timing, translating these metrics into refined deployment curves. Tanker operations were equally central, as sustained air and ground combat would require continuous delivery of aviation fuel, diesel, and bunker fuel to forward depots and naval forces. Maritime resupply planning therefore incorporated convoy routing, tanker availability, and replenishment at sea, procedures to ensure endurance beyond initial deployment. The Ready Reserve Force expanded during this period, preserving additional cargo ships in maintained status to be activated during major contingencies. Intelligence analysis consistently assessed the scale and activation speed of U.S. Sealift as a determinant of reinforcement credibility, recognizing that maritime mobilization signaled both capability and intent. This awareness contributed to the strategic weight carried by Military Sealift Command, whose activation patterns were closely observed in times of crisis. Technological modernization improved cargo tracking and communications, enabling more accurate forecasting of arrival times and reducing uncertainty in onward distribution planning. The cumulative effect of these measures was to transform Sealift from a background logistical service into a central operational enabler whose performance directly influenced the viability of NATO's forward defense. By the late 1970s, it was widely recognized within defense planning circles that without reliable maritime transport capacity, reinforcement assumptions embedded in war plans would collapse under the realities of tonnage demand. Military Sealift Command thus functioned as the maritime backbone of Cold War deployment strategy, ensuring that the geographic separation between the United States and its primary theaters of operation did not translate into strategic paralysis. Its integration into alliance planning demonstrated that global military posture depended as much on shipping schedules and port cranes as on combat formations positioned along contested frontiers. During the 1980s, as Cold War tensions intensified and NATO adopted doctrines emphasizing rapid reinforcement and high-tempo conventional operations, military Sealift Command's role became even more tightly integrated into formal war planning assumptions, particularly in relation to sustaining operations beyond the initial deployment phase. Planners understood that initial movement of equipment was only the beginning because sustained combat in Europe or other theaters would require continuous maritime resupply of ammunition, spare parts, fuel, and replacement vehicles over extended periods. Sealift schedules therefore incorporated not only first-wave shipments, but staggered follow-on convoys designed to maintain logistical depth. The ready reserve force was expanded and its activation timelines refined, with specific vessels assigned to designated cargo categories such as heavy armor, bulk munitions, or petroleum transport. Activation drills tested the time required to crew, provision, and deploy reserve ships, generating measurable readiness benchmarks that informed strategic assessments. Port infrastructure in the United States underwent upgrades to handle surge loading requirements, including improved roll-on roll-off ramps, expanded storage yards, and enhanced rail connections linking depots to embarkation, terminals. Coordination between military Sealift Command and European host nation authorities was rehearsed through exercises that simulated simultaneous arrival of multiple large cargo vessels, measuring offload speed and rail dispatch capacity. Tanker fleets remained critical to sustaining aviation operations and mechanized ground forces, and maritime fuel delivery planning accounted for anticipated consumption spikes during high-intensity combat. Intelligence assessments during this period often treated U.S. Sealift activation as an early indicator of escalation, recognizing that maritime mobilization signaled preparation for sustained operations. The visibility of large cargo ships assembling in U.S. ports or departing in convoy carried strategic implications beyond their immediate logistical function. Technological advances improved cargo management, with computerized tracking systems enabling more accurate synchronization between ship arrival and inland distribution. Sealift planning also incorporated redundancy measures, identifying alternate ports and routing options in case primary facilities were disrupted. The command maintained close coordination with NATO logistics headquarters to ensure compatibility between maritime deliveries and forward depots, including pre-positioned equipment sites. Exercises conducted in conjunction with NATO reinforcement scenarios validated the throughput of maritime corridors, reinforcing confidence that heavy divisions and sustainment stocks could be delivered within required timeframes. Analysts within the Department of Defense increasingly recognized that the scale of U.S. global commitments made Sealift indispensable, as no other mode of transport could match its volume capacity. By institutionalizing reserve activation procedures, port surge planning, and coordinated tanker operations, military Sealift Command ensured that maritime logistics remained aligned with evolving operational doctrine. Throughout the 1980s, its performance metrics were embedded in wargaming simulations and contingency planning models, anchoring strategic calculations in the practical realities of cargo tonnage and transit time. In this manner, military Sealift Command became not merely a transportation service, but a defining factor in the feasibility of U.S. Cold War plans, linking industrial production and continental stockpiles to forward deployed forces across the Atlantic and beyond. As Cold War planning entered its final phase in the late 1980s, military Sealift Command's importance was measured not only by the number of ships it operated, but by the precision with which maritime transport was integrated into joint and allied operational timelines. War games conducted at the strategic level increasingly relied on detailed Sealift activation curves that specified how many ships could be brought online within defined time intervals and how much tonnage could be delivered to specific ports during successive weeks of conflict. These projections were grounded in activation drills and documented performance data rather than theoretical assumptions, reflecting decades of institutional learning. The command maintained updated readiness assessments for each vessel category, including roll-on roll-off ships, break-bulk cargo carriers, container ships, and petroleum tankers, ensuring that planners understood the realistic availability of maritime lift under varying contingencies. Coordination with the ready reserve force provided surge depth, while commercial shipping agreements offered additional capacity that could be drawn upon if escalation required expanded throughput. Port vulnerability analysis became part of planning, identifying alternate embarkation and reception sites to mitigate the risk of disruption. Fuel logistics planning incorporated both sea transport and afloat replenishment capabilities, acknowledging that sustained naval and air operations depended on uninterrupted tanker delivery. Intelligence assessments continued to evaluate Sealift capacity as a core component of U.S. reinforcement credibility. An adversary doctrine recognized that maritime interdiction could significantly affect the tempo of U.S. deployment. This awareness reinforced the emphasis placed on convoy planning, routing security, and coordination between naval escort forces and logistics shipping. Sealift data were embedded in NATO reinforcement models, ensuring that maritime delivery rates aligned with rail and depot throughput capacity on arrival. The integration of cargo tracking technologies and improved communications reduced uncertainty in scheduling, allowing more accurate forecasting of arrival windows and onward distribution. As geopolitical tensions began to shift with political change in Eastern Europe, military Sealift Command remained fully integrated into contingency plans, reflecting its structural role within U.S. global strategy. Even in the absence of active conflict, readiness reviews continued to measure activation timelines and cargo handling performance, preserving institutional knowledge accumulated since the early Cold War. The cumulative record demonstrates that maritime transport capacity defined the outer boundary of feasible U.S. war plans, because without sufficient sealift, reinforcement timelines would exceed operational tolerance. Through disciplined fleet management, reserve activation planning, port coordination, and integration with allied logistics systems, military Sealift Command ensured that continental industrial strength could be translated into sustained overseas military capability. Its essential role lay not in combat engagement, but in guaranteeing that heavy equipment, fuel, and sustainment supplies crossed oceans in the quantities required to support prolonged operations. In this way, military Sealift Command became an indispensable logistical foundation of Cold War war plans, anchoring strategic commitments in the measurable realities of maritime throughput and ensuring that global defense posture was supported by organized, rehearsed, and scalable sea transport capacity. In evaluating the cumulative impact of military Sealift Command on Cold War war planning, it becomes evident that maritime logistics shaped strategic feasibility in ways that extended beyond individual deployment cycles, influencing force posture decisions, alliance coordination, and industrial mobilization assumptions. The United States structured much of its global defense architecture around the expectation that heavy equipment and sustainment supplies would move by sea in defined waves, meaning that divisional reinforcement timelines, fuel stockpile depth, and ammunition expenditure models were all calibrated against projected sealift throughput. This alignment required continuous coordination between ship activation schedules, port infrastructure readiness, rail interface capacity, and forward depot availability. Transforming maritime transport into a foundational planning variable rather than a peripheral service. Readiness inspections of reserve vessels, maintenance of government-owned cargo ships, and contractual arrangements with commercial carriers ensured that additional lift could be mobilized under crisis conditions, providing depth to contingency models. Wargaming simulations incorporated specific tonnage flow assumptions tied to sealift activation curves, reinforcing that operational tempo in Europe or other theaters was constrained by the rate at which heavy cargo could cross oceans. Tanker operations were embedded in sustainment planning, supporting not only land forces but naval and air components whose endurance depended on steady maritime fuel delivery. Intelligence monitoring of shipping activity during periods of heightened tension underscored the strategic visibility of sealift mobilization, as concentration of cargo vessels in embarkation ports was interpreted as an indicator of preparation for sustained operations. This strategic signaling dimension elevated the importance of military Sealift Command beyond logistics management, positioning it as a measurable element of deterrence credibility. Technological modernization improved scheduling accuracy and cargo tracking, reducing uncertainty in arrival forecasts and enhancing synchronization with inland distribution networks. The command's institutional structure allowed for scalable response, expanding or contracting activation in accordance with crisis severity while preserving core readiness. Even as political transformation at the end of the Cold War altered the strategic landscape, the accumulated infrastructure, procedures, and activation doctrine developed over decades remained embedded in defense planning frameworks. The historical record demonstrates that without assured maritime lift capacity, U.S. commitments to defend allies across oceans would have lacked operational substance. By guaranteeing the movement of armored vehicles, munitions, fuel, spare parts, and sustainment supplies in the quantities required for prolonged conflict, military Sealift Command converted industrial capacity and continental depth into forward combat endurance. Its integration into NATO reinforcement plans and global contingency models illustrates how Cold War strategy was anchored in the practical mechanics of cargo scheduling and port clearance, as much as in combat formations and alliance declarations. Through disciplined preparation, reserve fleet management, and integration with Allied infrastructure, military Sealift Command ensured that geographic distance did not translate into strategic paralysis. In doing so, it became an essential enabler of Cold War war plans, grounding global military commitments in the quantifiable realities of maritime transport capacity and sustained logistical flow. In the final assessment, the role of military Sealift Command in Cold War war planning illustrates how maritime logistics defined the practical limits and possibilities of American global strategy, because every reinforcement timeline, sustainment forecast, and industrial mobilization model ultimately depended on the capacity to move vast quantities of material across oceans. From its origins as the Military Sea Transportation Service through its mature structure as Military Sealift Command, the organization developed a scalable fleet composed of government-owned vessels, reserve ships maintained in reduced operating status, and commercial carriers integrated through formal agreements, ensuring that surge capacity could be activated under crisis conditions. Sealift tonnage projections were embedded in NATO reinforcement plans, linking embarkation ports in the United States with reception hubs in Europe through carefully sequenced cargo waves aligned with rail and depot throughput. tanker operations were synchronized with projected fuel consumption for air and ground forces, recognizing that sustained combat endurance depended on uninterrupted petroleum delivery. Readiness inspections, activation drills, and port exercises generated documented performance data that replaced theoretical assumptions with measurable throughput metrics. Intelligence assessments treated sealift activation patterns as strategic indicators, underscoring the visibility and deterrent significance of maritime mobilization. Technological improvements in cargo management and communications enhanced scheduling precision, reducing uncertainty and enabling tighter integration between maritime arrival and inland distribution. As force posture debates fluctuated during the Cold War, sealift capacity provided strategic flexibility, allowing the United States to maintain heavy formations at home while preserving credible reinforcement potential abroad. War games conducted at the strategic level incorporated activation timelines and tonnage flows derived from military Sealift Command data, confirming that maritime throughput established the outer boundary of feasible operational tempo. Even as the geopolitical confrontation of the Cold War receded, the institutional knowledge accumulated within military Sealift Command remained a testament to decades of preparation centered on overcoming geographic distance through organized sea transport. The historical record demonstrates that the credibility of American defense commitments in Europe and beyond rested not solely on forward-station troops or airlift capacity, but on the disciplined management of ships, ports, tankers, and reserve fleets capable of sustaining prolonged overseas operations. By transforming the oceans from barriers into transport corridors governed by scheduled cargo flow and rehearsed activation procedures, military Sealift Command anchored Cold War war plans in the measurable realities of maritime logistics. Its essential function lay in ensuring that industrial production, armored divisions, ammunition reserves, and fuel stockpiles could be delivered in sufficient volume and within required timeframes to support sustained conflict. In this manner, military Sealift Command became indispensable to Cold War strategy, embedding the mechanics of sea transport at the core of global military planning, and proving that maritime throughput defined the endurance and credibility of United States war plans across the Atlantic and beyond.